All right, recording is rolling. It is Wednesday, February 14th. So I have a box boat buoyancy lab for you guys today, which involves Archimedes principle. Yesterday, about the last 10 minutes of class, I went over this page that I just handed you guys. Right? So let's look at this again real fast to bring you back into the fold of physics. Remind you guys the last thing you saw in this class. Right? So you guys had a night sleep on this, think about it. Right? And then right. All right, and then I will get you guys these aluminum squares. This is the other part I have to give you guys, right? So you guys can fold this into some kind of boat shape, right? And then put weights in it. And you guys got a bucket of water, right? Right, so what's the deal here? So your goal is design a box boat with, okay, just this aluminum square, and it's 12 centimeters by 12 centimeters, right? That's what I'm about to give you guys, okay? To maximize the weight that the boat can carry. So you'll take your boat, right? Okay, this isn't the best folded boat in the world. But you guys see it folded up each side 1 centimeter, right, for this one, right? And kind of crimp the corners, right? But then you start stacking in lab weights, right? So you guys got a box of lab weights and put this in your bucket of water, and it should float, right? Now you can keep stacking lab weights until it goes down just to bring the water up to the brim, where it's still floating, just barely, right? And that's like the maximum weight that boat could carry, right? So then, free body diagram. What would the free body diagram look like on this, right? So we talked about this yesterday, but just throw these questions, guys, get you guys thinking. Right. So draw a free body diagram for the boat. The last 10 minutes of class today, I'll come back and I'll debrief you guys and see how close you guys got. Right. So what is buoyant force equal to? Say some equation. Yeah. What's the weight of object? What is what? Right, maximum gravity field. What's the density of water? We're kind of mix and match, maybe two different sets of units got to juggle today. I got grams and centimeters, and then I got kilograms and meters, right? So density of water, what is that in grams per cubic centimeter? Like, guys, if you have the box is 1 centimeter by 1 centimeter by 1 centimeter, you fill it with water, right? How many grams of water is that? 1, right? Versus this other unit, kilogram per cubic meter. Guys, think about what that means. What if I have a big old box? It's 1 meter thick by 1 meter thick by 1 meter thick. You guys see it right here? Fill that with water. How many kilograms of water is that?
Quite a bit.
Quite a bit. That's right. How about 1,000? 1,000. Okay. What's gravity field? Can I get centimeters per second squared or meters per second squared? Bet you guys know that number. Right? What is okay? Then some equation types. Right now, if you're taking good notes yesterday, maybe you have to see your notes from yesterday. What is y in terms of x? You guys see? If you start off with a flat aluminum square, 12 centimeters by 12 centimeters, you start fold up the sides, and you kind of see it here. You guys see the more I fold up the sides, guys, the more I fold up the sides, what's happening to the size of the base? It's getting smaller and smaller, right? Right. So then I labeled here's the full 12 centimeters. X could be the amount that you fold up the side. Y is the remaining side of the base, right? So the base could be y by y, right? What is y in terms of x? And then what is the volume of the boat? Something to do with like base times width times height. But what is that in terms of like the original 12 centimeters and x and y? Right? Then you can do a substitution. Right, again, I'll debrief last 10 minutes of class. See if you guys got this. Right. Table of values. So for different values of x, try out. So what if I fold it 1 centimeter, 1.5 centimeters, 2, 2.5, 3, 3.5, right? What's the corresponding y, the corresponding volume, and the corresponding maximum possible buoyant force, right? All right. And then a couple of graphs on the back. What's y in terms of x? Right now, you guys just told me the bigger that x gets, the smaller that y gets. Do you guys think this could be kind of a downward sloping graph, right? Y in terms of x, right? But what exactly is that going to look like? Right? The equation for that might be whatever you write in this line right here. That equation might match that graph. Right? And then, right, one's a little bit trickier. What is the maximum possible buoyant force as a function of x? How much you fold up each side, right? Now, just remind you guys here. Into yesterday, I told you guys if you don't fold up the sides at all, you just have a flat square. Pop that in the tank of water. It's just right. It can't hold anything. So the point 0, 0. I'll tell you guys that the point 0, 0 is on here, right? But if you fold up each side 6 centimeters, isn't that just taking this and fold it in half? Which would also give you 0 volume. So that's another point. The point 6, 0. You guys got that? 0, 0 and 6, 0 are both points. Okay. And then in the middle, it'll be some kind of upside down curve. Now I'll tell you guys too, it's not an upside down parabola. So it doesn't necessarily max out at 3 centimeters, which a parabola would, but this is not going to be a parabola, so maybe that's not the case, right? So where does it max out, right? Right, where does it max out? Right, and I also set up a little dimensional analysis table to help you guys out here, right here. How many guys are in calculus? How many guys are in calculus? Okay, if you are, you might notice that you could actually treat this as an optimization problem. You could solve this with calculus, right? If you're not, then that's right. You can just do this empirically and see like how can you fold this boat to carry the most weight? Okay. All right, so I'm going to give you guys these aluminum squares. You guys can fold different shaped boats, pop some live weights in, I'll walk around, help you guys out, and then I'll debrief you guys the last 10 minutes of class.